Transfer function definition here. Given a first-order differential equation that describes a fictitious system, يعني system خيالي, and the differential equation is the derivative of yt plus 2yt equal xt. Now, if we take the Laplace of both sides and set the initial conditions to 0, we get this from Laplace transform properties, which is the differentiation in time dy by dt equal x s times s. Now, if we factor ys, we end up with ys times s plus 2, close the bracket, equal to xs. Then hs, which is the transfer function, this is the transfer function, hs, equal ys over xs equal 1 over s2, s plus 2. So the transfer function is, this is the output of the system response, this is the input here, the output is the ratio of ys over xs, or the output over the input in the frequency domain. And this, so hs equal to ys over xs, and ys equal 1 over s plus 2, like here, times the input, which is xs. Now, this is equivalent to time domain xt convolution with gt yt. In here we have the convolution is, in time domain, is equivalent to multiplication in a frequency domain. So to get ys, we simply multiply xs times s plus 2, 1 over s2, or this one here where this hand moves. On the other hand, yt equal gt or xt convolution with gt, or vice versa, gt convolution with xt, which is yt. Here yt is the output, here xt is the input, and gt is the system. The system transfer function is, the system function is 1 over s plus 2. Okay, the transfer function is ys over xs. Now, if we take the in Laplace domain, we define a symbol s, and then we use this command inverse Laplace. We just type it in this way. We get the answer of 1 over exponential, the exponent of 2 times t. So in Laplace or frequency domain, we have 1 over s plus 2 times 1. We put it as 1 because we assume the input is as delta Dirac, or the impulse function, and if we take the Laplace transform for it, we get 1. Okay, now the answer here in time domain yt equal minus 2t, which is the convolution of xt with must be t here. So convolution in time domain is equivalent to multiplication in frequency domain as a property of this transform. And notice is yt is the solution for this differential equation. So we find the solution through the use of Laplace transform. Thank you.